Hey, hi. In this video, we're gonna see how to host ELK stack on AWS EKS. ELK stands for Elasticsearch, Logstash, and Kibana. So ELK stack provides an observability stack on managed Kubernetes like EKS. Here we're gonna see how to define the required components of ELK cluster on Amazon EKS, and then finally we see that how does this ELK stack helps us to absorb the logs present on the Amazon EKS cluster and tries to put that into a particular dashboard called Kibana. So here what we see in this demo is we're going to see how to spin up an Amazon EKS cluster with using Terraform. Here then we will show you like how to deploy the components of ELK, which is actually a microservice based solution or microservice based observability solution, which contains a file bit, a pod or file bit application which actually extracts the logs from the Amazon EKS pods, and then we're gonna use the Logstash component which actually receives the log extracted by the file bit and converts into that logs into a specified format, and from there Logstash going to push that logs into the Elasticsearch. Elasticsearch is a very complex and very compact the log analytics storage service which actually provides you both. In the sense, it provides you storage, log storage plus log analytics capabilities have been provided. And on top of that, we also deploy a service called Kibana. So Kibana is nothing but it's a service which actually helps us to visualize the data that is extracted as part of observability, right? So under the hood, the solution works something like this. We will host FileBit system on the Amazon AKS as a pod, which actually extracts the logs from the all your Kubernetes cluster, and then pushes that logs into the Logstash, which is actually acting as a kind of a bin for the logs, and it has a capability to convert the logs into a specified format. That is the peculiarity of the Logstash component here. Then Logstash will also be configured to create an the log index in the Elasticsearch, and that log index can be visualized in the Kibana, and from there you can do a log analytics, you can build alarms, you can build the the visualization of the logs or metrics. So a lot many things can be done on the the final component, that is Kibana, right? So Kibana is nothing but an UI, while the other components are acting as a kind of a backend services that is hosted on Amazon EKS. All right. Okay, so this is basically a very quick walkthrough of ELK on Amazon EKS or AWS EKS. Now what I do is I'm gonna take you to the my source code here. I have created a dedicated source code which is actually helps you to understand the complete stack, that is how to host the ELK stack on Amazon EKS for observability purpose, or basically for extracting the logs from the EKS and doing a log analytics job on that. Yeah. So here what I do is I'm going to quickly walk you through the the complete source code here, and then we're going to see how to use the GitHub actions to deploy the stack which actually creates the EKS cluster first, and then on top of the EKS cluster we're going to see how we can host the EKS ELK stack on that, which actually provides us the observability layer, right? So as you might have seen my another video, that is where I have shown you like how to create a EKS cluster with using the Terraform, right? So that is the same pattern here. So for now I have I have the workflow file something like this. I'm going to just walk you through this, and then we're going to see the source code as well. So here this is my 02-elk.yaml file. So this is a file which I have created for this demo purpose, which will help us to spin up the cluster and deploy the the ELK resources as well. So here it has a name, that is ELK stack, and it is being declared to dispatch. Basically this workflow will be invoked by manual. That's what workflow underscore dispatch means. We have a job, so I have declared only one job which does the complete task of this demo. So in this one we are using the the publicly available runner called Ubuntu latest, and on the default configurations we are using the shell bash command lines. In the steps of the job, so we have a checkout, and then basically so here we are using here I'm using the Terraform cloud for hosting the the state of my complete cluster plus ELK. So we're gonna see like how to use the app that is the Terraform the app.terraform.io, which I'm going to show you right away. So here we are using the Terraform Cloud APIs to connect to that, the dynamic workspace created in the Terraform Cloud, right? And that's where the remote execution will happen. So here we are using the Terraform init, Terraform validate, Terraform plan, and Terraform apply stages are here. And then, so here actually, once the Terraform apply is being done, the clusters will be created. And then what we are doing is, after that, basically, we are using the, the kubectl commands to install the ELK stack on the EKS cluster. So here, for that sake, we are actually taking the context of our AWS account with using the IAM user access key and secret access key is being used here, right? So these access key and the secrets are kept in the GitHub action secret, which I'm going to show you right away. And after that, we are just validating whether I have set the context of my AWS account or not. Then we are actually installing the kubectl, right? And then this is the where actually, what we are doing is, first we are creating the cluster, and then we are actually taking the, the cluster context by updating the kubeconfig file. To update the kubeconfig file, we are using the AWS EKS, AWS CLI command. The AWS CLI command here is AWS EKS update kubeconfig and the name of the cluster, which actually creates a kubeconfig file under the context. Then we are sleeping it for 30 seconds just for to make sure that everything is everything is in place. And then we are actually, this is the place where we are actually doing running the actual kubectl commands to deploy the ELK stack on the EKS cluster. Right, so here we are doing the cd to this particular path where I have kept all the the manifest files to deploy the EKS cluster. It includes a huge list of .yaml files, which I'm going to walk you through that as well. And finally, we are actually displaying the services being created for after the deployment of the cluster. Right, so other files you can ignore for now because the my the my ELK clusters are relevant to only this 0 to hyphen elk.yaml file. Yeah. All right. Now next one, let's go to the modules files. I'm going to close this file for now. If you go here and try to close all the files like this, currently in the root, we have we have 4 files. First one is the provider. So basically, provider.tf file is nothing but where actually we declare the providers of Terraform that is required for deploy the complete stack here, right? So here we are using the AWS provider and we are using the random providers. We are using the Kubernetes provider. Note that I'm also showing you a very good way of taking the elevating the Kubernetes providers and try to interact with the Kubernetes resources of Terraform with the AWS EKS servers. Okay, so which I'm going to show you right away. And here we are actually configuring the backend information. So here I'm using the app.terraform.io. So if I go back to the app.terraform.io, so this app.terraform.io is nothing but this is the Terraform cloud. In the Terraform cloud, I have organization called cloudquicklabs, which is my channel. And in that one, I have created a workspace called Amazon AWS, AWS EKS workspace. In this workspace, I have a set of the variables called access key ID and access key secret. So this is an independent IAM user which I created. The access key and secret of that particular IAM users have been configured here. So with using these credentials, the remote execution of Terraform will happen. If I go back to this one, so this is where that's the reason we have configured that, and this is my workspace name. Likewise, down the line, so we are just producing certain data like this, and then this is the place where we are actually doing the providers configuration, that is Kubernetes provider configurations, like how you set up the AWS CLI with using the secret key and the access key ID and the secret key. Likewise, Kubernetes also sets the context of a Kubernetes cluster with using the cluster certificate, hostname, and token, which is here it is getting dynamically, yeah. And that is the that is the one of the good thing that you can learn from this video. Then we have a provider for AWS, and then the the random string being generated here, right? So likewise in the output, so basically it just outputs a cluster ID, cluster endpoint, and cluster names are being outputted here. In the main, so here I'm using the modularization of the Terraform to create the required stack here, right? So here main.tf file is meant to create the infrastructure that is a Terraform infrastructure, right? That is to create a EKS cluster infrastructure with using Terraform. So here we are having a module for EKS where I'm passing these many parameters to create my cluster. Since this is a demo video, I have created a cluster with only one node and one node group. One node group containing one, only one node number, yeah. And the rest all are nothing but parameters required to create a EKS cluster. Likewise, so here we are also creating the VPC because VPC is needed to spin up the EKS cluster. Okay, so here I'm using pure EKS cluster with managed node groups. All right, so that is where the component here, and we have a elk.tf file. So this is where I was showing you, and I was more enthusiastic to explain this concept that once the EKS cluster has been created with using Terraform, you're gonna elevate the Kubernetes provider to take the access to the EKS cluster or nothing but authorize the Kubernetes cluster API server and try to invoke the API commands to create the objects in the Kubernetes cluster like namespace, like deployments. Lot many objects you can create in the EKS cluster with using the API server APIs. Okay, so here Kubernetes namespace, create a Kubernetes namespace is only possible if you have access to the Kubernetes cluster, and that is happening with this provider that I have shown you here. Okay, so with that being said, let me quickly go to the inside the module files, and then we're gonna see what is that I have defined in the ELK cluster, ELK folder, which is the heart of the demo. In the EKS, if I open this one, so this is the very simple file. It contains the definition of creating an EKS cluster. If you see here, we are using the AWS underscore EKS cluster and defining the EKS cluster configurations here. So this is where a cluster is being created, and we are saying, right, so we are creating a cluster. To that cluster, I am attaching an EKS node group, and that node group has a certain configuration, that is scaling configuration is there, remote access configurations are there, and depends on configurations are also been there. Yeah. Now with that, here we are actually declaring the so here declaring our security group attached to the node groups. Yeah. And then we have a IAM role that is required for cluster access level. Right. So here are the the IAM roles and policies are being attached. So here we are creating IAM roles, and then you see that role policy attachment is happening here. All right. So nothing more. I'm going to share this files in the GitHub. I'm going to share these files to my GitHub repository. GitHub repository link is being shared in video's description. You can find it from there. So here we have a certain outputs being calculated. That is the endpoint, Kubernetes kubeconfig certificate authority date, cluster ID, endpoint, and the cluster names. Similarly, variables which are declared here. So I'm going to quickly go to the VPC as well. So here in the VPC, so basically you can ignore this file. This is not required. I'm going to delete that for you. In the main, basically here we are creating a VPC which is required to create a cluster. Creating an internet gateway. We need internet gateway because we are actually trying to access the the Kibana Kibana UI from the internet, right? So for that case, we need to have an internet gateway. And then we need to have the random shuffle. Basically, you see that, and then we are creating a subnets. So here I'm creating only two public subnets, and then we have attaching the route tables with a certain routes. All right. Okay, so that is the configuration about the VPC and the output and variables respectively. Yeah. All right. So now let's go to the main part of the demo, that is ELK. So ELK, as I said, ELK stands for Elastic, Logstash, and Kibana. So here, as I said, so ELK, as I said, nothing but constitution of, it's basically a cluster of 3 microservices. The 3 microservices includes Elasticsearch, Logstash, and Kibana. So Elasticsearch, Logstash, and Kibana are not enough. So we also need to have something like so basically scraper or the log scraper called FileBuild. So here we are using a FileBuild as a log scraper, which actually scrapes the logs from the cluster and pushes it to the Logstash. From the Logstash, it is going to the Elasticsearch. From the Elasticsearch, we are actually interfacing to the Kibana, right? So here, let me quickly walk you through each component, each file here, which we have declared in as a ELK cluster, right? The first one is Elasticsearch deployment as the namespace. So this is actually creates a one replica of Elasticsearch microservice pod. So here kind is the deployment, and we have a metadata that is Elasticsearch, and the namespace is given as a ELK. Note that this ELK namespace is being created by the Terraform with using the Kubernetes provider. Okay. Next one, that is in the specifications. We are actually replicating one node, and then here actually we are actually using the selectors, that is the app selector equal to Elasticsearch. In the template, we are actually having the metadata, that is I am labeling this application as Elasticsearch. In the specification, we have a container. So basically we are declaring the containers. So this container is being created from this particular image, which is publicly available image. In the resource, basically it is best practice to distribute the resources for the particular application here. That is for Elasticsearch. Okay. Since I'm deploying such a complex cluster, complex ELK components on this EKS with using one node. So this is very, maybe unique one, right? So you need to understand to do like this. Okay. So here we are having a memory request at nothing but memory at are basically resource reserved at the idle case, and resource defined for the the upper case, that is for the limits. And the environment we are actually having a single node. Yeah. So likewise for the Elasticsearch, basically now we created a pod. Now in front of the pod you need to have a service so that somebody can talk to this particular application. So here we are having a service that is actually Elasticsearch service, and it is created in an ELK namespace, and in the selectors, basically in the specifications, we have a application called Elasticsearch, and this service is available on the port number 9200 TCP ports. And this type of the service is nothing but load balancer, in the sense our pod, this Elasticsearch pod, will be available on load balancer. So load balancer will not matter here because I'm creating only one the replica, right? So when you create two replicas, maybe in that case it will help us. Okay, now let's go to the file bit cluster role binding. So I'm going to go to the first to the file bit deployment, and we're going to go to the other components. So likewise for the Elasticsearch deployment, so for the file bit, as I said, file bit is a component or is an application in the EKS cluster which will scrape the logs from the Kubernetes cluster. Okay, so for that case we need to deploy an application called FileBit, right? So FileBit, it has the the deployment, the type is deployment, and it has a metadata like this, right? And the application label is FileBit. Yeah, and then in the specification we are actually creating only one replica. This is the demo, but in production you can keep it multiple replicas so that it gives a high availability. Then we have a selectors, we have a templates here. So in the template we have a metadata, that is labels. In the specifications we are having this image, that is the the Docker elastic code.beats. So this is basically file bit image. Arguments is nothing but execute. In the security context we are actually giving full access, that is admin access has been given here. In the volume mount, basically for configurations, we are actually keeping the configurations here, yeah, in this subpath. And then in the logs, okay, so basically log volumes are being kept underneath this path. Okay, so this is just a path being created. You can change this value according to your need. Yeah. And then similarly for volumes, volume configurations, so we're having a config map. So this is a config map being created, and this is the file. Basically you can copy these these configurations as expected here. Okay, all right, so this is basically a practical the demo of how to create the ELK stack. So the configurations, are some part of the configurations are still left for your usage purpose, so you can try to modify accordingly. We are done with the deployment. Let me go to the services. So likewise for Elasticsearch we're creating a service. So here a service called FileBit service, very simple service. Yeah. And then so basically you see that it is neither a load balancer service type, or neither the node port, neither cluster port. Yeah. So if I go back to the cluster one, so this is type is something like this. Yeah. And then if I go back to the Logstash, so Logstash, this is basically they are all listening on certain the certain types of the the types of the certain types of the services. Okay, so here, okay, so let me go back to the service account. Okay, this is FileBit service account. Okay, I got confused here. So here we are creating a service account because, as I said, FileBit is a component within the ELK which actually scrapes the the logs from the EKS cluster, right? So to read the logs, the application within the Linux needs to have permissions. For that sake, that application has to provide it with a service account. So we are creating a service account called FileBit. Okay, and this is what it is talking about. And then if I go to the FileBit config map, so this is basically one side we are deploying the application, the another side we are actually configuring the application, right? So if I go to the deployment, so here you see that there is a config map. So the config map is basically pointing to the config map which I'm going to explain it right away. So if I go to the FileBit-config map, so this is where the config map has been created. Underneath the data you have a FileBit.yaml file being created, which actually tells from where the lag has to be extracted and to which output the lag has to be done. Okay, so this is where, remember that this is nothing but the configuration where we are telling the FileBit, hey, go and collect the logs from this path of the Linux system and put it into this particular target, like that. Yeah, so here we are actually scraping the logs, enable equal to true, and from where the log has to be extracted, right, from the path of the Linux system called where.log. Yeah, all right, and from there actually outputs to a Logstash the service, right? So we're gonna see that, how does this Logstash appears here. Okay, so with that being said, let's go to the other parts of the file bit, that is creating a cluster role. So here a file bit cluster role has been created with resources like namespace, pods are resources, and the permissions given is nothing but get, watch, and list. Okay, because it needs to have a get, watch, and list permission, so that it can the watch, get informations can be done on the pod and namespace level. Yeah. Okay, so now once we have a cluster role, we need to bind that cluster role. So that is where this is happening. This is a cluster role binding, and these are all the metadata. And the subject is nothing but this is a service account. So this is our service account name, that is the file bit, and the role mapping in the role references. So basically this is where the role reference is happening. Yeah, that is cluster role. Okay, basically this is, you can just copy it as it is. Okay, so basically now what we did is we have covered the two components of the ELK, that is Elasticsearch and file bit. Okay, so now we are done with the two component. Let's go to the next component called Logstash, and finally we see Kibana. In the Logstash, first let's see how to deploy the application, and then we're going to see the service and then config maps. So in the deployment, so we have a deployment, and these are all the metadata been defined here. And in the specification, we are actually creating only one replica of this pod, that is Logstash pod. Since I'm using only one cluster, so I'm keeping it very minimum replicas, but in your case you can change the number as per the the resource configuration of your EKS cluster. In the selectors, we are actually using the app selector equal to Logstash. In the template, where we are actually declaring the container templates actually, so this is the label name to the particular app, particular app deployed. Then the containers, inside the containers, we are actually giving the name of the container called Logstash. The image of this Logstash application or pod is coming from here, this path. And then this is nothing but this pod will be available on port number 5044. This is what we saw in the file bit configurations. Okay, that is in the config map. Right, in the volume mount, basically the volume mount of this particular file is belongs to this one. Yeah, this is the path. Similarly, volume configuration, so we will see that the Logstash config map as well, so that is being pointed to this config map. Yeah, now we are done with the Logstash deployment. Let's go to the Logstash services. So we created a pod. In front of the pod, we need to create a service, right? A service in the Kubernetes world is nothing but it's basically a logical grouping of the pods. Okay, so basically when you group replicas of a same application pods, if you keep if you keep a constant IP address to a particular logical the object in the cluster called service, so basically the third party or from the internet somebody can reach to that service, so that they can talk to the backend the pod application. All right, so here we are having a we are actually creating a Logstash service. So this is a Logstash service, and then so these are the metadata. Selectors is nothing but Logstash, and basically Logstash is heading on port number 5044. Yeah. Now I was talking about a config map. So this is, remember, this is very very important part of the the demo here. So this is where actually talks about how the Logstash collects the data from the source, that is file bit, and pushes that logs to a destination called Elasticsearch. Right, if you see here, so we are actually declaring that in a config map, and the config map name is nothing but logstash-config. This is the names in the data. Basically we are declaring the Logstash configuration file. So here input, so input will be heard from the beat application. You see that beats is a beat application on port number 5044, and the output is nothing but basically this is acting as I said, this is acting as a pipeline between the source and destination. Here is the source is the bits, and final destination is nothing but Elasticsearch. In the Elasticsearch, you see that host is available on this particular. This is a service name, and on this port, the host will be available, and the index to create in the Elasticsearch is nothing but this index. That is, it is created with a name called beat with the metadata. Nothing but the name of the the beat application, and version of the application, and then the the date appended. Okay, so it's dynamically creating that index, okay, which I'm going to show you right away. Okay, so with that being said, basically this is how we are declaring the Logstash the microservice component on the EKS cluster. So likewise, we go to the final component, that is the Kibana. So Kibana is nothing but it's a visualizing service which is hosted on the EKS, and it is a part of ELK, right? So here we are actually also deploying the ELK application, that is Kibana application, with using deployment. And then we have a metadata declared here like this, that is name is Kibana and the namespace is ELK. Remember that all the components of the ELK are being pointed to a namespace called ELK, and that namespace is created by Terraform. So for your information, I'm giving that. Yeah. In the specifications, we are actually replicating only one part here. So these are all the selectors information. And here in the template, we have a metadata defined, that is application label equal to Kibana. In the specifications, we are actually declaring, from where the image will be pulled in, and what is the pod name, something like that. And the port will nothing but, this application will be listening on 5001, 5601. Yeah, generally. Yeah. All right. In the service, basically right now we created a pod. Now in front of the pod, some service should be available, and through which only this, the Kibana application will be accessible. This is where the magic is happening. So here, if you see the API version equal to version 1, kind equal to service, and this is the metadata. In the specification, we are having the app selector, that is nothing but, to which service, to which part this particular service belongs to. That is where the selector is talking about. Okay, if I go back to the deployment, in the metadata, so you see that, application label, right? So application label is nothing but basically, Kibana of type app. Yeah. And that is where being used in while creating the services. Okay, so basically when you are creating the service, to which application it has to create a service, that is nothing but with using a selector with reference of app selectors in the port. So basically on which port this service will be listening. So it will be listening on, TCP port 5601. Yeah. And target port is also same, like that is 5601. What type of this service is nothing but, this is nothing but a load balancer type of service. Okay, so as I said, service can be of type like load balancer, node port, or cluster port. Yeah, so here we are using load balancer. Okay, so with that being said, if I go back to the Elasticsearch, so here we are actually declaring two services as load balancer. One is Elasticsearch, the other one is nothing but, the Kibana. In the basically, Kibana service is listening on the load balancer. Okay, so in total, this ELK stack is going to create a two load balancer in your, the ECS service, which I'm going to show you as well. Now if I go to the Logstash service, because basically, there is nothing like name. This is basically to the point. Basically very simple. The services here. Uh, okay, so that is about the Logstash. Yeah. All right. So with that being said, I have completely walked through this particular source code. This source code reference will be provided in the Git. In this video's description, you can find it from there. You will be, receiving this exactly this same source code available in the video's description. You can find it from there and try it from your side. Okay, so with that being said, what I do is I'm going to commit this source code for the demo purpose. I'm going to do something like this. Remember that here we are creating the cluster dynamically, we are deploying the ELK stack dynamically. That is the uniqueness of this video, right? Which is nothing but everything is managed as infrastructure as a code, deployed as a version control. Okay, so now we have committed the code, and if I go to my GitHub repository, so this is AWS underscore EKS labs. Okay, if I go to the VS code, so in the VS code, we have a repository name called AWS EKS labs, and that is the same app, same lab here. This is a publicly available repository. So here we are having everything is been done here. Now let's deploy this application to my to my AWS account. Okay, before that, I need to tell you something. What is that? If you go to the settings of the repository and go to the secrets variables, okay, and go to the actions, secrets and variables, go to the actions. So here I have created three secrets, that is access key ID and secret access key and the TFC API token, which I explained while explaining the GitHub action workflow file. Okay, so these are all the repository secrets are been referenced and respective job is been done from the workflow files. Now if I click on the actions, and there should be a name called 0-Elasticstack. How do you identify that? Is if we go to the GitHub, go to the workflows and click on 0 to ELK. So here in the top you have a name called 0-ELK stack, and that is what the workflow file we need to invoke. Now I click on that and click on a run workflow from the branch main. I have only single branch for this demo purpose, so I'm going to choose that branch. And let's see a live demo of this particular the stack deployment. As you see here, currently it is loading. While it is, if you see here, this is basically a live demo of everything. In the sense, I have tried to explain you the solution setup with using the design diagram. I walked you through the code basically, and then now I'm giving you the CI/CD pipeline based infrastructure creation, infrastructure deployment as well. Now we will wait for a couple of minutes so that the deployment will go on. Okay. Remember that here I have already created a EKS cluster, or else creation of EKS cluster will take nearby 10 minutes, and then the deployment of application will take 1 minute. So basically it will take a 10 minutes. Since the EKS cluster is already created, so it will not take that much time. If you see here, our EKS cluster is basically created. You see that, it's basically created. Yeah. And that's the reason there are no changes. Okay, now it is running the Terraform apply, which is where actually I'm just running the creation of Terraform cluster. That is, creation of EKS cluster with using the Terraform. And then we are using the Kubernetes provider and trying to create a ELK, the namespace in the cluster with using the, the Kubernetes configurations. Okay, so if I open this one, here you go, right? So we have a output called Kubernetes namespace. Okay, so which is basically which means that it is already created. Okay, now here you go. So there are no changes even in the Terraform apply. So that's the reason it has jumped to the next stage. That is where it actually, configuring the AWS credentials are basically setting the basically it is setting the, the AWS account context, right? And then we are actually installing the kubectl. Remember that we are running the GitHub actions, right, where the kubectl will not be installed. So we need to install the kubectl. Make this step in your workflow file mandatory. And then we are actually using the kubeconfig, nothing but we are running the AWS CLI command, that is to update the kubeconfig file. And then wait for 30 seconds. Basically, once the 30 seconds, why I'm waiting for 30 seconds, it's just to provide a certain gap so that, the API server can respond. So after 30 seconds, it is actually deploying the, the ELK cluster. So to deploy the ELK cluster, I'm just running the basically, the kubectl apply commands, right? Here you go, right? So first one, you see that we are actually doing a cd to the ELK model, modules and ELK folder, and then we are running the kubectl apply command one by one. So if I down the line, you see that it says deployment unchanged, right? There are so many things it got unchanged. Okay, so basically you see that there are lot many things unchanged because it's already deployed. So all the components of the Kubernetes cluster are not changed, or ELK components or ELK ELK microservices are did not change basically. Yeah. So here finally we are actually validating the kubectl configurations are just running, kubectl get service, so that I will get the endpoint of the, the respective services and try to use it. All right. So rest all options, you see that, it has went green. So what happened is basically we created a cluster, we deployed the ELK stack on that cluster, and we queried the, the component with using the command called kubectl get service. Yeah, so you see that kubectl get service from the namespace ELK, and it has reported us back. Yeah. And if we go to this one, so we have a service called Kibana, and that is listening on this port called 5601. Okay, now let's try to access it. Okay, so here one more time, our deployment is green now, so we can try to access this endpoint over port number 5601. I'll go to the browser and then click on this, just put this. Remember to put the node, the port number, that is 5601, because service is listening on that port. Now once you are done this one, so it will automatically take you to this page, that is which is actually, the Kibana page, and click on basically add data. And from there you can click on the options. You see that we have Kibana options, we have Elasticsearch options, we have observability options, we have security options. Okay, so for now I'm going to show you in the Kibana, so whether it is able to discover the, the configs. Basically, is it able to discover the index? Okay, so then you can click on the index management. Here you go, right? So we have a namespace called we have the index, that is Elasticsearch index, has been created with the name like filebit version hyphen 2024-03-011, which is nothing but today's date. Okay, and now it has already populated a storage of 39.1 KB data is already been populated. Okay, so likewise, basically what did I show you here is we have seen that, so how to deploy the Amazon EKS cluster, basically creation of EKS cluster with using the Terraform, which is actually infrastructure as a code. And then we also show that, how to set up the GitHub actions definition so that it can deploy that EKS cluster. So not only that, we also saw the, the specification file, that is nothing but, the manifest files that is required to deploy the ELK cluster on Amazon EKS. ELK is a very component, very complex application of observability type. So where we have seen that how to deploy the filebit microservice, how to deploy the Logstash microservice, how to deploy the Elasticsearch microservice, and Kibana microservice. Okay, finally, how all these microservices are interacting each other and trying to provide us the observability layer. Okay, that's what I have shown you. Finally, before I wind up, I'm going to show you to the one more interesting step, that is, this is my AWS account where we have actually spinned up the EKS cluster, and here you go, module hyphen EKS cluster has been created. If you go to the, basically you see that there are all the, the resources. Go to the compute, we should be able to see one node group here. So this is the node group, and you can explore the resources as well. So here you go. So it will take certain time, and but basically it will also show you those data, so you can also figure it those data after some time. Yeah, and then I will take you to the EC2 service. Basically, if I go to the EC2, and here we can see the load balancers are being created, that is two load balancers. If I go to the load balancers, okay, and refresh it, so here you go, right? So if I open the load balancers, so here are the our load balancers. If I click on this one, so we should able to see the load balancer, that is this is the load balancer. Yeah, okay. So this is basically listening on this particular port TCP9. This is basically for the Elasticsearch load balancer, and the other one is belongs to basically to the Kibana. So I'm going to open that as well. So not only from the service, you can also get to know about this from the another tab as well, right? Here you go. So our Kibana, basically Kibana is responding like this. Yeah. All right. So with that note, I have shown you everything from scratch to end on the ELK cluster, how to deploy, how to define, deploy, troubleshoot, right? So everything I have shown you in this video. Okay. So before I wind up, a kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.